Hi, my name is Alejandro Gomez.
And I'm Sharif Botros, and we will be solving this circuit right here with Thevenin.
The reason we Thevenized it is because we want to know what happens to this resistor right here, which is our load, R4. The first step that we have to do is remove the load, make points A and B in our circuit. So that's what we did right here. The first thing we need to do now is find out RTH. So RTH is the Thevenin resistance. It's not the whole resistance to a circuit. It's basically the resistance for A to B. Now, as you can see, we remove the sources differently. Voltage sources get a wire across, shorten it, and current sources, it's an open circuit. This wire shorts this. It basically makes it so the circuit A and B does not even see these two resistors here. They don't even factor into our calculations. So what we end up is that our RTH equals our R2, which equals, let's see here, 5.1K. Thanks. So that's our RTH. We're gonna come to this near the end once we've actually Thevenized the circuit. What we need to do now is to find ETH. Now to find it, we need to do a little bit of superposition because we have two sources. We have a voltage and a current source. So that's what we split up here. We first find our R total, so we can do our calculations, finding out our I total. So R total is the sum of all of these resistances. R2 is not even going to factor into our equations here. So we already automatically know that our current is going to be 0 here. And then we can do our calculation, 5.1K. And then with this, we can do all of our calculations. For example, we can find out our I total. I total is V total divided by R total, 1.568 milliamps.
Now that we have the results for our first current source, we work on our second source. Our second source is a current source, and it starts out like this, but we simplify it by making it more clear that R1 and R3 are in parallel, and once we do our calculations to get their equivalent, we can get the equivalent of R1 and R3 in parallel with R2 in series. Once we plug in our values, we can take them so that we can find our Thevenized voltage, which would equal 9.85 volts. And we can take that with our original RTH and get all the results that we require right here when we plug them into our Thevenized circuit. So we have ETH is 9.85 volts, and we have 5.1K is our RTH, and we have 8.2K is our R4 or our RL. And if we do our math, we'll find that IT equals 740 microamps, which IT equals I4 since they're in series. And of course, once we do our calculations here, we'll get 6.068 volts for our V4, and our power will be 4.49 milliwatts. And that's pretty much how you Thevenize this circuit.